Okay, thank you. My name is Björn Jernström. I'm the founder and CEO of Ferroamp. I would like to tell you about one of the main underlying trends in the energy industry. For the past 100 years, we had centralized generation. And for the past 10 to 15 years, we've built distributed generation with PV and wind. And now we're moving into what some analysts call the energy cloud. This is when we have true bidirectional flows of energy. We're integrating multiple energy networks with information structures. And this will require new products and new services, and that is what we do. When we started this development a couple of years back, we identified 3 technologies that have become mainstream now, and these are solar cells, energy storage, and electric vehicles. These 3 technologies have one thing in common, and that is they all run on DC, direct current. So then it makes perfect sense to develop such a system. This is why we developed the Energy Hub concept, where we use a DC nanogrid. The Energy Hub acts as a bidirectional inverter, like a bridge between the AC utility grid on one side and the local DC nanogrid within the building on the other side. On this DC grid, we connect solar cells, energy storage, electric vehicles, and even small-scale wind. And the benefits with this concept is that we can use one single inverter for doing all this, when our competitors need to have 2 or 3 or even 4 inverters to do the same thing. On top of that, we get scalability, so you can easily adapt this system to different applications. Also, it's future-proof because you can easily expand it when the needs change. On top of this is a cloud-based energy management system that gives you high-resolution data and detailed control of every aspect of the system. So this may be a bit tricky to actually visualize how this is put into action. So that's why I brought some customer cases. So this is in Västervik on the Swedish east coast. You can see there's a barn there on the lower part of the picture. They're installing 32 kilowatts of solar cells, but the nearest grid connection point is 800 meters away. But since we're using a high voltage DC topology, in this case we cut the cost of £8,000 just by reducing the size of the cable, or 17% of the total project budget. Here's another case, Gothenburg in Sweden. So this construction company is building 6 new apartment buildings where they will use second life bus batteries from the local electric bus line. These batteries are used to store excess PV electricity during the day and also to reduce the peak load from the grid during the winter time. We are supplying all the power electronics and the DC grid topology. Here's the third case in Oslo, Norway. You probably know that Norway has the highest penetration of electric vehicles in Europe, and consequently that requires a lot of charging spots, and consequently that puts a lot of stress on the grid. So in this case we're supplying energy storage to reduce the peak load on the grid, and also our patented ACE technology that reduces the phase unbalance from a lot of EV chargers. Now, some of you are probably thinking, but this is vastly different applications. This can't be scalable. Well, yes, it can, because it's a modular system. So on the left-hand side, you have the Energy Hub, which is the main product, bidirectional inverter. You have optimizers for connecting solar cells and storage, and you have our battery modules. Everything is then interconnected with our cloud-based energy management system. So in these 3 previous examples, the only thing that differs is the combination and the number of these different modules. Yes, it's scalable. Okay, some quick facts about the company. This year we're recording sales of about 500,000 euros, which is up a factor of 10 from last year. We're 17 employees, we have 4 patent families, we're based in Stockholm, and we're also now setting up a factory for producing our battery modules in Suzhou, 2 hours outside Shanghai. So this spring we will be raising about 2 million euros for expanding into new countries in Europe, and investors can then look at an exit in 4 to 5 years to some targeted buyers. So this is your chance to invest in a really cool technology before everyone else realizes how brilliant this is. Thank you.